Hello, class. We're about to start sections 4, 5, and 4, 6 to complete this week in Math 131. So 4 or 5 starts on page 432, and then 4, 6 starts on 438. But what we're going to do, because in 4 or 5, as you see here, we have that we're to do problems 1 through 13 odd. But what I'm going to do, I'm going to do 3 through 11 odd. And then you will have to do problems 1 and 13 on your own. So we're actually going to start on 433 with me doing it. But then you will have 1 and 13 to do on your own. And you can ask any questions that you may have. So with that being said, let's get started here. All right, so we're on page 433. And now we're going to start with problem number 3. Problem number 3, we have 4x squared plus 4x plus 1 equals 0. Okay, now it says identify the values a, b, and c, and then solve the equation using the quadratic formula. Round your answers to the nearest hundred. Verify your solutions graphically. Okay, first of all, we have to have this in quadratic form, which is y equals ax squared plus bx plus c, which we have it here. And then we notice here that the y and the 0 replaces each other. So our A here would be 4. Our B is also 4. And our C is 1. Okay, so now the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So now we're going to substitute. We will have negative 4, because b is 4, plus or minus the square root of 4 squared minus 4 times a is 4, and then c is 1. All divided by 2 times a, which would be 2 times 4. So we will have x is equal to negative 4 plus or minus the square root of 16, because 4 squared is 16, minus 4 times 4 is a negative 16 times 1, which would be minus 16, all over 2 times 4, which is 8. Okay, so now this will give us x is equal to, this will be negative 4 plus or minus the square root of 0, all over 8. Now, this is really x is equal to negative 4 plus, we know the square root of 0 is 0. So it'd be plus or minus 0 all over 8. So we could rewrite this. This would be x is equal to negative 4 plus 0 over 8. And then also negative 4 minus 0 over 8. Now, since we're dealing with zeros, these two values will end up being the same. So this would be x is equal to negative 4 plus 0, we know is negative 4 over 8. And this will also be negative 4 over 8. So our answer here would be x is equal to a negative 1/2, comma, negative 1/2. And we know these are the same. So your final answer would just be x is equal to a negative 1/2. And that would be your final answer for this problem. Now, typically you will have two answers here, but in this case, x would just equal to a negative 1/2. Now, we want to prove this graphically as well. So we need to grab the Desmos calculator. Now, we get the Desmos calculator. And what we have here, we will type in the equation, the 4x squared plus 4x plus 1. And then when we graph here, if we notice here, we have our x-intercept is negative 0.50, and we know that's negative 1/2. So we proved that it's only one solution here, and we're done with that problem. Now, we're going to move on to the next problem. Let me pull it up here. Okay. The next problem is problem number 5. We will have 2x squared minus 6x plus 3 equals 0. So this is lined up in the proper quadratic form or trinomial form. And we will have a is equal to 2, b is equal to -6, and c is equal to 3. So we would do the quadratic formula. It'll be negative, the opposite of -6, plus or minus, the square root of, we know it's b squared, so it'll be -6 squared minus 4, a is 2, and c is 3. All over 2 times a, so that'd be 2 times 2. So now we will have +6 plus or minus the square root of, this would be 36. 4 times 2 is 8, times 3 is 24. So minus 24 all over 4. So we have x is equal to 6 plus or minus the square root of 36 minus 24 is 12 all over 4. Now, we can pull out, well, just to show this by hand, this would be 6 plus or minus. The highest perfect square we could pull out of 12 is 4. So we could break that up as the square root of 4 times the square root of 3 all over 4. So this would give us 6 plus or minus 2 square root 3 all over 4. Now, we will pull out what these three values have in common, 6, 2, and 4. All of these have 2 in common. So this will give you 3 plus or minus the square root of 3 all over 2. So when you write your final answer here, your final answer would be x is equal to 3 plus the square root of 3 over 2, and 3 minus the square root of 3 over 2. Now, they did ask us to write our final answer as a decimal to the nearest hundredth. So we go right here to the calculator, and let's type this in. We have 3, then I'll do the division. So it'll be 3 plus 3 plus the square root of 3 all over 2. So we round the 2 decimal places here. So x would be 2.37 or approximately 2.37. And then we'll do OR. And then we would do the second value. Now what's nice about the second value is all we have to do is take this plus out and put a minus there. And then it'll be OR x is approximately 0.63. So just to write this in proper form, we had 2.37 comma 0.63. And that will be your final answer. Now we have to prove this using Desmos. So we would type in the formula. I could turn this graph off here, but we would type in the formula 2x squared minus 6x plus 3. And as you see here, our x-intercepts are 0.63 if we round it to 2 decimal places and 2.37. So we proved it here. Now, I'm not going to do the graph for 7. I'm just going to go through and we're just going to solve this for problem number 7. So let me get here. Problem 7. Oh, we have a double parenthesis. 7. We have 2x minus 1 and x plus 2 equals 1. Now, we would actually be done with this if this would have equal to 0. But since it doesn't, we have to actually go through and solve this. So I don't know what is happening to my okay, I think that's a little clearer. Okay, so we need to multiply these two parentheses. So we will end up with 2x squared plus 4x minus x minus 2 equals 1. All right. So we can subtract 1 on both sides. We add 2x squared. 4x minus x is 3x. Negative 2 minus 1 is negative 3. And that equals 0. Okay, so now we could do our A, B, and C. A is 2, B is 3, and C is negative 3. So we put in a quadratic equation. This would be negative 3 plus or minus the square root of 3 squared minus 4 times 2 times negative 3 all over 2 times 2. So it'd be x equals negative 3 plus or minus the square root of 9. And this would be, what's that, negative 8 or positive 24 all over 4. So this would be x is equal to negative 3 plus or minus the square root of 33 all over 4. All right, so now we write this out. We separate it. X equals negative 3 minus the square root of 33 over 4. Or is negative 3 plus the square root of 33 all over 4. So it's x is equal to, now we have to round this to 2 decimal places. So we go right back here to decimals. And we could do negative 3 minus, I should put a division, oh, no. Do this division sign here. So we have negative 3 minus the square root of 33 all over 4. So it'd be negative 2.19, comma, and we would change this to addition, and then it'd be 0.67. So, I'm sorry, 0.69, not 67. And these two are your final answers. Okay, so now we did that. So now we need to go on to the next page. Let me flip over to the next page here. Then we would do problems 9 and 11, and then we would be done with this section. Now, number 9, it says in exercises 9 through 11, determine the x-intercepts of the graph algebraically. Then check your results graphically. Okay, so this is supposed to be some type of review from what we've already covered. So let's take a look at number 9. We have y is equal to 3x squared plus 6x. Now, if we're trying to solve for the x-intercept, that means that y is automatically 0, because x-intercept is when y is 0. So we have 0 is equal to 3x squared plus 6x. Now we're supposed to do like we did in the previous problems in the previous lessons. Find the greatest common factor of these two terms. 3x squared and 6x, the greatest common factor is 3x. And that will leave us x plus 2. Now we would set both of these equal to 0. So we had 3x equals 0 and x plus 2 equals 0. And then we would solve for x. Divide each side by 3 and x equals 0. Subtract 2 on both sides, and x equals -2. So when we write our final answer here, since they want us to write it as an x-intercept, we're going to have two ordered pairs. So, and this is going to be and because we have two values that actually work here. So it'll be 0, 0 because x is 0 and then y is 0. And then here to be -2, 0. So these are your two x-intercept points. Now, as far as graphically is concerned, I'm going to do this one real quick. It's basically done the same way that we did the others. All we have to do now is just type in the formula, 3x squared, or the equation, plus 6x. Let me turn this graph off. All right, so this is the graph here. We look at where it hits the x-intercept. We got -2, 0, and then we also have 0, 0. So we proved it graphically as well. Now, we're going to move on to problem number 11. Now, problem number 11, like I said, will be the last problem we cover from this section, and you'll be responsible for problems 1 and 13. So we have f of x is equal to 2x squared minus x minus 5. Now, if you notice here, they do not have a greatest common factor, but just like in problem number 9, since we've been asked to find the x-intercept, that means y is 0, or you could say f of x is 0. So it'd be 0 is equal to 2x squared minus x minus 5. Now we will have our a, b, and c. Our a is 2, our b is -1, and our c is -5. So now, since they want us to do it algebraically, we have to multiply a times c. So it'd be 2 times -5, which is -10. So now we will find all of the factors of -10. So we'll do 1 and 10 and 2 and 5. First, we would do the positive values. Now, since we're trying to multiply to give us -10, but add together to give us -1, the larger values would become negative. So when we add these together here, this 1 and -10 will give us -9, and 2 and -5 will give us -3. So that doesn't work. So we cannot do it in the typical form that we did it before. This is where the quadratic formula comes in. So we will use the quadratic formula using this a, b, and c. So it'll be the opposite of -1 plus or minus the square root of -1 squared minus 4 times 2 times -5, all divided by 2 times 2. So x is equal to 1 plus or minus the square root of -1 squared is 1. -4 times 2 is -8 times -5 is a positive 40. All over 2 times 2 is 4. So x is equal to 1 plus or minus the square root of 41 all over 4. So this could be separated as 1 plus the square root of 41 over 4 and 1 minus the square root of 41 over 4. So we could have x is equal to, now we could put this in our calculator. Let me just clear up a couple of these first. So putting this in our calculator, we have 1, then I hit the division key to get that fraction. Then we could do plus the square root of 41, all divided by 4. So it'd be 1.85. So that'd be approximately. And then we will make this a minus. And then that'll be a -1.35. Now, these are the x values, but remember also, when you use the quadratic formula, it's also giving you the x-intercept. So this would give us 1.85, 0. And then it also would give us a -1.35, 0. Now that's if they wanted us to round it. But if they wanted us to keep it as an exact value, this is how you would write the exact value. I actually didn't leave myself enough room, but I'll write it over here. The exact value would be 1 plus the square root of 41 all over 4 comma 0 and 1 minus the square root of 41 over 4 comma 0. This would be the exact value. This would be the estimate. This would be the exact value. It just depends on what they ask you for. Now we're done with this section here. Now let's look back at our syllabus. We need to do section 4.6 on page 438. So let's go there. So we need to go to page 438. Okay, now looking back here, we have problems 1 through 4 all. So what I'm going to do, I'm just going to do problems 2 and 4. And then you will be responsible for 1 and 3 as well. So you will need to turn in all of the problems to me. But you will do 2 and 4 on your own, and you can send me any of your questions. Okay, so problem number 2 actually starts on page 439. So let's go over here to page 439. Problem number 2, it says use the following data set to perform the task in parts A through E. Okay, it says determine an appropriate scale and plot these points. Okay, look here. We look at our x values. We go from 0 to 12. So if you look here along this line here, it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we can actually go by ones here for this scale. So it'd be 0, and then it'd be 1 through, it look like 14 or 15, 0 through 15. And so we could go by ones for this scale here. Now the y values, we start here at 5, but we go to 310. And if we count up here, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So basically, it looks as though we would basically be going by 30s here. So if we go by 30s here, this would be 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, and then this up here would be 330. So now, so basically you could label that. And remember, here is the x values, and over here is the y axis as well. So, but I guess what I'll do, just for the sake of you seeing this, let me see, I think it was like 11 of them. Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, good. Then I'll do this here. All right, just to show you a little illustration. This would be your y-axis, and this would be your x-axis here. All right, so with the y-axis, right, I said 30, so this would be 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, and then up here at the top would be 330. Just to show you how you're supposed to label that. And then here down the side, remember we have 15 here. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right. So this is basically it here, and this would be the 0 for both of them. All right, so now we have these graphs here. Now I'm not going to plot these points. I'm going to show you this on the Desmos calculator. But to show this on the Desmos calculator, let me pull up the calculator. Okay, I'm going to move this over a little bit so you can see me typing it in. So first we would add a table. And then we would type in these values. We have 0, 3, 6, 9, and 12. And then we would have 5, 28, 86, 180, and then 310. Now, if you notice here, you really don't see much of the graph here. So you could click on this wrench and you could go here to the x-axis. We can go here from 0 and we could go to 15. Then we could do the y-axis. We can go from 0 to 330. All right. And as you see here, we have the points. Okay, so this is what the graph is supposed to look like. Now, see if I could push this over just a little bit. All right. Now we go here to B. It says B, use your graphing calculator to determine the quadratic regression equation for this data set. Okay, so listen, remember, let me pull this up real quick. Remember, whenever we did an equation for the quadratic, is y equals ax squared plus bx plus c. All right. So we need to use this equation in order to get our quadratic regression model. So this is how we would do it. The first thing we would do, we start off with our y, so it'd be y sub 1. We will go here to ABC and get our tilde. Now remember, it's a x actually it's supposed to be x1 squared. Let me bag it up. So it'd be ax1 squared. Wait a minute, let me see something here. All right, so it'd be ax1, and then that'll be squared, plus bx1, and then plus c. Now when you come down here, it gives you your A, B, and C. And we're going to round to 3 decimal places. So let me pull up this camera so we can write this down. So I'm going to have to move this over a little bit. All right, so we're going to do B here. So we have y is equal to 1.984 x squared plus 1.590x plus c is 5.114. So that is our equation. Now we're going to go here to C. It says graph the regression equation using your graphing calculator. Let me see, to compare the predicted outputs with the outputs given in the table. All right. Okay. So they want us to mainly do calculator action here. They want us to graph the regression equation using your graphing calculator. So now they want us to use the graphing calculator to do this regression model. So we will have y is equal to 1.984 x squared plus 1.590x plus 5.114. Now I'm going to have to expand this out. Let me take out. Okay, now, if you notice here, if I turn this off, it turns back red. Turn it back on. It's basically laying right on top of that line. Okay, now, let's look at the next question here. It says, we did graph it here. It says, use the table feature on your graphing calculator to compare the predicted outputs with the outputs given in the table. So basically what they want us to do, they want us to take this equation and make it into a table. So we click here, hit the plus. Oh, no, you know what? Actually, no. We click here and hit the wheel. And then we hit the table feature. Now we're going to type in the numbers that we had from here. The numbers that we had were 0, which we have here. Matter of fact, let me just type them in. So it'd be 0, and then we would have 3, then 6. I don't know why it has -0, but it should be 0. 3, 6, and then this would be 9, and then also 12. Now what we could do, we could look here and compare it here. 0, this is a little over 5. 3, this is a little under 28. 6 is close to being the same. 9 and also 12. If you round it to the whole numbers, they all would be the same. So it's very, very close. All right, so now that was D. Now E, it says predict the output for x equals 7 and x equals 15. So what they want us to do is to put it in our table. So we'll put 7 and then we will put 15. And it gives us the values here, rounded to 3 decimal places or 2 decimal places. Let me write this out here. All right. So, you know, D we had to put on here. So this is E. So E, we will have 113.46 and we will have 475.364. That would be our answers for E. All right, now we go here. I said I wanted to do problems 2 and 4. So now we go here to page 440. So we could do problem number 4. Now problem number 4, we have quite a few things to do here for problem number 4. But let's take a look. It says, according to Facebook, its revenues continue to increase from 2012 to 2016. The following table indicates Facebook's revenues for those years. Note that the revenue R is given in billions of US dollars. It says, first thing, A, create a scatter plot of the data using a graphing calculator, which is basically what we did here before. I'm going to leave this here just in case we need to use that again. Well, no, I could just take that out. Okay, so we have this. Let's create a table. And they give us since 2012. So we'll type in these values for X and these values here for Y. So we have 0, 1, 2, 3, and 4. We don't need 5. Then we would type in the values, 5.09, 7.87, 12.47, 3 is 17.93, 27.64. Okay, so we put in those values, and then we could take a look at the scatter plot. Okay, now if you notice here, we really can't see it that well. That's because our scales is off. So we will hit this wrench, And then we could go here for the x values. We could start at 0. And then we could go all the way up to, let's just go to 8. Okay, next, the y values. You notice here that the y values start at 5.09. So we could start at 5. Or you know what? Let's start at 4. And then we could go all the way up to, let's go to 30. All right. Now we take that in. We have all of our points. Now, we're seeing that we have all of our points. Okay, good. We can still see it here. Okay, it says using your graphing calculator to obtain a quadratic regression function for these data. So we will do the same thing we did before. It'll be y1. We'll get our tilde. And then we will have a x1. And then we would take that to the second power. Plus bx1. Then plus c. Now we replace these values for this equation. So we will have y is equal to 1.051 x squared plus 1.310 x plus 5.271. So that will be our equation. Now we go back here and it asks us to graph the equation from part B on the same coordinate axis as the data points. Does the curve appear to be a good fit for the data? Explain. Okay, so basically what they want us to do is to type in our equation. So we will have y is equal to 1.051 x squared plus 1.310x plus 5.271. Now, if you notice here, if I turn off this purple, well, let me do this. Let me turn off the black. And you notice the purple remains. If I hit this again, it covers the purple almost exactly. So it's a good fit. So it says, explain, does the curve appear to be a good fit? I would say yes, because it seems to cover the curve perfectly. So you can write that. And then also we could look here at our r squared is close to +1. Remember, we went over that in a previous lesson. So since it's close to +1, then we know that it's a good fit as well. All right, now it says D here. Use the model to predict Facebook's revenue in 2027. Do you have confidence in this prediction? Okay, so remember, when we did our graph here, it was since 2012. So 2027 would be 15 years later. So what we could do, we could type in 15 here. Oh, you know what? Actually, no. Actually, I was supposed to come here and then hit the wheel, then hit the table, and then I could type in 15 here. And it would give me this amount, this 261.396. So it'd be y is equal to 261.396 billion. And then the question was asked, also with that question, do you have confidence in this prediction? Well, I would say this. If we go here on this graph here, it looks as though it's a little outside of that graph. Well, actually, wait a minute. Let me go up here. We take this here and move this along the graph. Hold on, got to take this in a little bit. Yeah. That's kind of hard. Well, let me do this here. All right, there we go. And we need to get down here to 15. 15, we get 261.497. So it's very, very close to what we had before. It's very, very close. So I would say according to this model, I would say according to this model, I would be confident the answer would be close to the actual amount. But I would be very confident that it'll be close to the actual amount. Okay, now we move on. Now we come to E. It says, in what year does the model predict Facebook revenue will reach 100 billion? So there's a couple ways we could do this. This is basically asking us when Y would equal 100 billion. So we could go right here to the calculator and we can move along this line here until we get to where Y is equal to 100. Or very, very close. So if you notice here is real close between 8.6 and 9. So we could go here and we could put in 8.7, 8.8, 8.9. So 8.89. Let's see, 8.9. Oh, that's a little over. So 8.892. 91. So about 8.892 would be very close. Well, 8.891 I think would be a little closer. Okay, so that's one way of doing it. So then that would mean that it'll be basically in the year 2020, because if it's 8.891 since 2012, that'll be in 2020, even though it'll be close to 2021. But there's another way that we're supposed to do this, and this is how we could do it and show it, and this also in your calculator. But first, let me show you how you're supposed to write the equation. So what we're saying is that we want 100 equal to the equation that we came up with, which was that 1.051x squared plus 1.310x plus 5.271. Okay, now we can actually graph this by leaving a graph here and put in here that y is equal to 100. And we can see where the line hits it at. It hits it in two spots. At a -10, which we know we can't use. Let me see something here, because this graph is not, there's too much going on with this graph. Let me go to the wrench and let me change this a little bit. Let's go back from 0. So I want you to be able to see this very well. Say 0 to 20. All right. And then for the y, I still will want 0 to, let's go to 280. All right, now, yeah, this looks a lot better. Okay, so now we have our graph here. You notice this line here is the y equals 100. It hits it here, which is at -10. So we know we're not really going to pay attention to the negative value for x. But if we look here, it'll be 8.889. So that means that that would be 2020. Okay. And one of the reasons why we can't look at this -10 is because from 2012, that would take us back down to 2001, real close to 2002. And Facebook was not actually producing revenue at that time that it would have got to $100 billion. So it's actually this value alone here. So it'd be in 2020. So we would say in 2020, Facebook revenue should reach 100 billion. All right, now I showed you how to do this basically with the calculator, and we can also do this by hand as well. So I have to show you how to do this by hand, and then we would be done. We would take the same equation, but this time we will subtract 100 on both sides because we want this to equal 0. Then if we subtract that, that would give us a negative 94 point, what's that, 729. Yes. Okay, so that'll be a negative 94.729. So now we will list our A, B, and C. A will be 1.051, B will be 1.310, and C will be a negative 94.729. So we will use the quadratic formula. So it'd be x is equal to, we would do a negative, the opposite of 1.310 plus or minus the square root. It'll be 1.310 squared minus 4 times 1.051 times a negative 94.729 all over 2 times 1.051. Now, what I would suggest that we do is put this in a calculator here. And we know one has to be negative, one has to be positive. So we'll do negative. Let me do the division. Oh, I guess I didn't. All right, let me do the division first. Then up top, we would have negative 1 point, well, we could just do it exactly the same. 1.310, close our parenthesis. Now listen, I'm just going to do the plus, not the minus yet. So it'll be plus the square root of parenthesis 1.310, close your parenthesis. And we will square that parenthesis. And then it'll be minus 4 parenthesis 1.051. Close our parenthesis, open up another parenthesis, negative 94.729. Close our parenthesis. Now we're done with the numerator. And our denominator would be 2 times parenthesis 1.051. Now, if you notice here, we get 8.891. If we round to 3 decimal places, that still would take us to 2020. So we get 8.891. And then next, we would take this, we would go back here. And instead of it being added to this radical, we're going to subtract it this time. And that will give us a negative 10.137. Now we know this will take us back to 2001, so we can't use that. But this here would take us to 2020, because everything is since 2012. So that's basically how you would do it by hand. But your answer would still be the same. All right, so we are done. And also remember, you have to copy all of these problems in addition doing the two problems from the previous lesson. I believe it was, let me take a look here. For the previous lesson for 4 or 5, you're to do problems 1 and 13 on your own, but you're supposed to do all the rest that I showed you how to do. And then for 4 or 6, you're to do problems 1 and 3 and still do 2 and 4, which I just showed you. So now we are done. And please contact me if you have any questions. Have a beautiful day.